Okay, in the previous session, I explained you about the some of the operations. Those are addition, multiplication, and properties of multiplication. And also, I explained you about the three important terms that are idempotent, involuntary, and nilpotent matrix. Idempotent is a square equals to a is known as idempotent. Involuntary, a square equals to I is known as involuntary, and nilpotent matrix, that is a power m equals to 0, then m is known as index of matrix. Okay, and today's session we are going to explain you about the matrix polynomial. Okay, matrix polynomial. What do you mean by matrix polynomial? Matrix polynomial is nothing but, for example, you know about the polynomial. It is the polynomial is, for example, consider any polynomial f of x equals to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus an x power n minus n. Okay, this is one of the polynomial. This is one of the polynomial. Okay, let any square matrix is replaced by x. Okay, then it becomes as matrix polynomial. Okay, I am only using the square matrix. Because why I am using the square matrix? Because in addition we must have the order should be same. For addition of matrix we should have the order must be same. Okay, for square matrix, what is the meaning of square matrix? The rows and the columns are equal. Okay, it's known as square matrix, right? So if rows and columns are equal, then we easily add the matrices. Okay, then now I am replacing as f of a. A is any square matrix of order n. Okay, a naught a power n plus a1 a power n minus 1 plus a2 a power n minus 2 plus so on plus an, sorry, small an. So is this representation is right? No, it is not wrong. It is wrong. Why? Any matrix cannot be added up with a constant. Okay, so what we can write here? I. What is an I? Identity matrix. Okay, identity matrix. So any constant is multiplied with I, then what will be the resultant? So is the same constant. So now we can easily add up with a. Okay, so the resultant matrix polynomial is a naught a power n plus a1 a power n minus 1 plus so on an into I. Now this is the matrix polynomial. Okay, now it became as matrix polynomial. This is the concept of matrix polynomial. Now I am going to explain you about the trace of matrix. Okay, now I am going to explain you about the trace of matrix. What is mean by trace? Sum of the diagonal elements. Okay, sum of the diagonal elements is known as the trace. Then and now let's see some of the properties. Okay, so the first property of trace of matrix is trace of Ka equals to K into trace of A. Okay. And the next one is trace of AB equals to trace of BA. Next one is trace of A plus B equals to trace of A plus trace of B. So these are the some of the properties which are useful. Okay. And next, now let's see about the transpose of matrix. Transpose of matrix. See, these are short revision. So I'm going very fast. So just note down this. Okay, very useful for MSET or JEE. Okay. Now I'm going to explain about the trace of matrix is completed. Now it is transpose of matrix. So what is meant by transpose of matrix? As simple definition that changing rows as columns and columns as rows. Okay. So for example, A equals to Aij. Okay. Then what about the A transpose that equals to Aji? Simple. It is denoted as A capital T or A small t or A small hyphen. Okay. So in the representation you are so confused. I think so. Most of the people are confused in the representation of transpose of matrix and inverse of matrix. So, and next, now a small concept that is conjugate of matrix. That is conjugate of matrix. Conjugate of matrix. What is the conjugate of matrix? Assume that A equals to I plus 2I, 3, anything 5, 3 minus 6i. Assume this in matrix. A simple thing, as you know that conjugate is and complex numbers exist in pairwise. So what is an conjugate of any complex numbers? If 1 plus I is a number in complex numbers, then what is its pair? I minus, oh sorry, I'm written 1. Now okay, 1 plus 2i is an 1 complex number, then its pair will be 1 minus 2i. Then what about the conjugate of matrix? Then conjugate of A will be, what will be the conjugate of A? That is nothing but I minus 2i, 3, 5, 3 plus 6 is the conjugate of this matrix. Okay. Then how you can represent a conjugate of matrix? Conjugate of matrix is represented as A bar. Okay. It is represented as like this. Okay. Now let's know about the symmetric matrix. Okay. Symmetric. So symmetric matrix. What is the simple definition of symmetric matrix? A square matrix is said to be symmetric if its ijth element is equals to the jith element. That is nothing but aij equals to aji. Okay. This is the simple definition of symmetry matrix. Okay, so for example, a symmetric matrix is written as A H G H B F G F C. So 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3 3 by 3 matrix. Okay, now just see, Aij elements are equals to Aj elements. Okay, so this is one of the symmetry matrix and it is said as A transpose equals to A. Okay, A transpose equals to A. Then now know about the skew symmetric matrix. So skew symmetric matrix. What is a definition of skew symmetric matrix? A simple definition: Aij element is equals to minus of Aj element. Okay, this is the simple definition. Okay, that is A transpose equals to minus A. Okay, A transpose equals to minus C. Okay, the one of the main key point of skew symmetric matrix is nothing but in diagonal elements are 0. Okay, diagonal elements are 0 in skew symmetric matrix. Okay, so now know about the properties. So the properties are for symmetric and skew symmetric both. Properties are nothing but any matrix is can be written as sum of symmetric and skew symmetric. Okay, any matrix, assume a matrix A, it can be represented as sum of the symmetric plus sum of the skew symmetric. Okay, is symmetric matrix and it is skew symmetric. This is one of the most important property. Okay, now the two properties which are I am going to say now are also very important. The mostly questions are asked based on these three properties. Okay, this is one of the property in the three properties. Now the two properties are also very important. Okay, just concentrate. Okay, that is, if A is symmetric matrix, then A power n is also a symmetric matrix for all n belongs to W. What is W? That is whole number. Okay, see, if A is symmetric, then A power n is also a symmetric for all n belongs to W. What is W? Whole number. Okay, if you multiply a symmetric matrix any time, then the resultant will be also a symmetric matrix. Okay, whereas in case of skew symmetric, in case of skew symmetric matrix, assume that now A is skew symmetric, then A power n is symmetric. Listen carefully, is a symmetric matrix. Now it is a skew symmetric matrix. Okay, then A power n becomes as a symmetric when n, if n equals to even. Okay, skew symmetric if n equals to odd. Okay, can you understand? As in case of skew symmetric matrix, A power n becomes a symmetric matrix if n equals to even number, and it becomes as a skew symmetric if n equals to odd numbers. Okay, if you assume any skew symmetric matrix, okay, if you square it, then it will be as a symmetric matrix. Okay, but when we cube it, it becomes as a skew symmetric. Okay, can you understand what I am saying? And one more thing is, null matrix is both symmetric and skew symmetric. Okay, symmetric and skew symmetric. Okay, symmetric. So these are the properties, important properties about the symmetric and skew symmetric, or transpose of matrix. Properties of transpose of matrix. Now know about the orthogonal matrix. Orthogonal matrix. Okay, orthogonal matrix. What is an orthogonal matrix? Which matrix is said to be orthogonal? A matrix is said to be orthogonal if a matrix is said to be orthogonal, matrix if A into A transpose equals to A transpose into A equals to I. Okay, note down. A into A transpose equals to A transpose into A equals to I. So the matrix A, here we use the matrix A, then the matrix is said to be orthogonal. Okay, so what are the properties? The properties of orthogonal matrix were also important. A into A transpose equals to I. Determinant of A into A transpose is equals to I. Okay, and that is, then just derive a simple formula. Okay, you know that in the determinants, okay, in the next video I will say about it. In determinants we have the property that we can write the both the determinant property. If you product the determinant, if you product two matrices and if you find the determinant, then it is equals to the product of individual determinants. Okay, that is equals to I. Okay, then you know that determinant of A and determinant of A transpose is always equal, because you are just changing the rows as the columns and the columns as to a row only. You are not changing the elements here. So the determinant value will become as equal. What is the determinant for A will be equal to its transpose. Okay, so in the determinants I just say clearly about it. Okay, don't miss the video of determinants. So now A det of A equals to det of A transpose. So I just say that equals to I. Then whole square equals to I. Okay. Then what is the determinant value of I? Determinant value of A is plus or minus I. Okay. This is the important. In MSAT, they will be asked directly that if A is orthogonal, what is its det value? Then you must write what you must write plus or minus 1. Okay, what's the determinant value for an identity matrix? It's 1, right? So then the det value of A becomes plus or minus 1. Okay, now orthogonal matrix is invertible. Can you understand what I am saying? Orthogonal matrix is invertible. Okay, is always invertible. From here we can derive that A into A transpose equals to I. Then what we can say that A transpose equals to A inverse. So inverse is always exist in orthogonal matrix. And one more thing, that is if A is orthogonal, and B is also an orthogonal matrix, okay, then their product AB is also an orthogonal matrix. This is also one of the important property. So if A is orthogonal and B is orthogonal, just assume that AB resultant is C matrix. Then C is also an orthogonal matrix. Okay, it's also an orthogonal matrix. So you should all note on these properties, very important for MSET also. Okay, as soon as I will finish the most concept, now let's know about the adjoint. Very important, the most confusable topic. Adjoint. Okay, let's know about the adjoint and their properties. First of all, you can write in a new page. It's so nice. Okay, adjoint. So how can you find the adjoint? How can you find the adjoint? I'm asking that. Let A is a matrix, then adjoint of A is, how can you find the adjoint of A? Adjoint of A can be found by using their cofactors. Okay, so adjoint of A equals to cofactor matrix whole transpose. Oh, what's this? Oh. How can we find the cofactor matrix of any matrix? Let A is a matrix, then the cofactor matrix of A whole transpose is known as adjoint. I am saying that. So how can you find the cofactors? Assume any writing the rough work. Okay, let us consider 2, 3, 4, 0, minus 1, 1, 1, 2, 1. It's a matrix. I just say only one example. Then find the cofactor of 2. Find the cofactor of 2. What is the formula of cofactor? Minus 1 whole to the power of I plus j into closing its corresponding row and corresponding column and finding the det. Okay, what is it here? Minus 1 minus 2 1 minus 3 minus here 1 1 1 is the I and j. I is 1 and j is 1. So minus 1 whole to the power of 2 1. That is 1 into minus 3, that is 3. Minus 3 is the cofactor of 2. So in the like, so same for 3 also, and we can find for all the elements cofactor in the same way only. And finding the cofactor of each and every element and writing in their order. So minus 3 is a cofactor of 2. Then replace the minus 3 in the place of 2. Minus 3 and x, y, what of the cofactors we get. And the transposing the whole cofactors. Now, after finding the cofactor, you may get the cofactors matrix of that corresponding matrix. So, by transposing that, you can get the adjoint. Okay. Adjoint of A. Now, I think you may have understood. Okay. Cofactor matrix of A. Cofactors of A whole transpose is known as adjoint A. So, in this way, you can find the adjoint of A. Then, find the properties are some of the properties which are most important. Okay. A into adjoint of A equals to adjoint of A into A is equals to det of A into In. Okay, this is the first property. A into adjoint A equals to adjoint A into A, that equals to det of A into In. What is n here? N is the order of the matrix. For example, what is the order for this? 3 by 3. Then n is 3. Okay. So, one of the important property. And the second property is, if A is non-singular matrix. Non-singular का मतलब क्या है? Non-singular है. Non-singular is det is not equals to 0. Okay, det is not equals to 0 of order n by n or n cross n. Then det of adjoint A is equals to det of A power n minus 1 in n minus 1. Most important property. Most important property. Okay. It should not be a singular matrix. It should not be a singular matrix. It should be a non-singular matrix. Okay. Det of adjoint of A equals to det of A whole to the power of n minus 1. Okay. And the next property is adjoint of Ka. Adjoint of Ka equals to K power n minus 1 into adjoint of A. Okay. And the next property, adjoint of AB equals to adjoint of B into adjoint of A. Reverse. AB, BA. Okay. Adjoint of Ka equals to K power n minus 1 into adjoint of A. We have the proofs also, but we don't need the proofs in the short revision. Okay. And one more property is adjoint of A power or A transpose equals to adjoint of A whole transpose. Okay. Next, sixth property, adjoint of A power K is equals to adjoint of A whole to the power of k. Note down all these properties, very important. Okay, and the next property is adjoint of adjoint A equals to det of A power n minus 2, you know about the n, into A. Okay, the next property is det of adjoint A is equals to det of A power n minus 1 whole square. Okay, these are the how many properties? 8 properties. Okay, are very important. Note down all these properties. Okay, each property, every property is important in adjoint of A. Okay, if you note all these properties, then I will go for inverse of matrix, so that today's session will be completed. Okay, I think so you noted. Next, let's go for inverse of matrix. Go for the inverse of matrix. Okay, what is an inverse of matrix? When we can say that inverses exist, there are some of the conditions and also one of the simple definition, that is a square matrix is a square matrix, capital A, assume that, is said to be invertible if there exists a matrix B such that AB equals to I. Okay, if AB equals to I, then what we can say that B equals to A inverse. So for a matrix A, for a square matrix A, the inverse is possible. Okay, the inverse is possible. So, and also as per orthogonal matrix, so we have some conditions and some of the tools, some of the key points that to make our calculation simple in any competitive exam, that as per orthogonal matrix, OM is nothing but orthogonal matrix, A into A transpose is equals to I, right? So A transpose is equals to A inverse. See how simple it is. Actually, inverse formula is adjoint of A by det A. Is it? This is the formula of A inverse. If for an orthogonal matrix, if they ask that for an orthogonal matrix, if they ask to find the inverse of matrix, we can easily find by transposing it. Okay, see how, what is the, now here you need to use a big calculations. First you need to find the adjoint of A and then det A and then dividing those. Oh, big process. But by doing that, you can just do like this. By transposing it, you can get the inverse of matrix. Okay, then for involuntary matrix, involuntary matrix. What is an involuntary matrix? If A square equals to I is known as involuntary matrix. Then A is equals to A inverse. For an involuntary matrix, the matrix is itself exists as a inverse of matrix. Okay. There is some proof also, but the proof is not needed here. Okay. Now I can say about the properties now. Some of the properties of inverse matrix. Okay, I said you that A inverse equals to adjoint of A by det A. Okay, inverse is exist only when det is not equals to 0. What happens if det is equals to 0 here? What happens? That inverse cannot be exist. So in questions they ask that which one of the matrix does not have its inverse. Then you can easily check its determinant. Then you can answer it easily. Okay. And second property, that is A into A inverse is equals to I. This is also one of the property. And then another one is K into A whole inverse equals to A inverse of K. All these properties has what is a proof, but I am not saying the proof here. Okay. And another one is A inverse whole inverse is equals to A. A inverse whole inverse is equals to A. A into A inverse equals to I. K into A whole inverse equals to A inverse by K. A inverse whole inverse equals to A. Then AB whole inverse equals to B inverse A inverse. Okay. And next, A transpose whole inverse equals to A inverse whole transpose. Okay. A inverse whole transpose. And next, A plus B whole inverse is not equals to A inverse plus B inverse. Okay. Okay. Then the last property, but not the least, it is also very useful. A power minus K, it can be written as A inverse whole to the power of K, also written as A power K whole inverse. Okay. 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 And the last property is inverse of diagonal, that is diagonal means only the diagonal elements are exist, remaining all are equal. Then the inverse of a diagonal matrix is its inverse of diagonal. Okay. Then what about its inverse matrix, that is 1 by k1, 1 by k2, so on 1 by kn. I think you may not understand this property. I just say, for example, assume A 0 0 0b0 0 0c is a diagonal matrix A. Then its A inverse can be written as 1 by A, 0 0 0 1 by B 0 0 0 1 by C. That's what I written here. Okay, for any order now. Okay, so again I am repeating all the properties. That is, A inverse can be written as adjoint of A divided by det A. For existence of inverse, the det should not be equals to 0. Okay, then A into A inverse equals to I, and K into A inverse whole square equals to A inverse by K. A inverse whole inverse equals to A in A. Then AB whole inverse equals to B inverse into A inverse. A transpose whole inverse equals to A inverse whole transpose. A plus B whole inverse is not equals to the A inverse plus B inverse. And A power minus K can be written as A inverse whole to the power of K or A power K whole inverse. The diagonal inverse of diagonal matrix is it can be written as the inverse of its diagonal elements. Okay, these are the things what I explained today. Okay, I explained you about the matrix polynomial, trace of the matrix, transpose of matrix, conjugate of matrix, symmetric matrix, skew symmetric, and also some of the properties. And I also explained you about the orthogonal matrix, adjoint of matrix, and inverse of matrix. Okay, then another session, in the next session, we can learn about the determinants. Okay, up to now you learned about the matrix. For matrix, up to now I done 2 videos. Okay, in the first video I explained you some concept. In the second video, so from up to now we complete a matrix, and next session I am going to tell you about the determinants. Okay.